All right, y'all. This is Andy-Mack, Andy and Mac. What we're doing today is we're going to be talking about trees. All right. So, Mac, what is a tree?
Okay, so first of all, why talk about trees? Trees are like the most basic data structure. Pretty much everything builds off of them. If you look into our map video, they're built off trees. Everything uses them in some facet. Um, and so trees are a basic container that works with a set of nodes, all pointing to two subsequent nodes. And so you can basically think of like, a family tree or just the roots of a tree. They go out, you have one, and then it splits into two more. And then it keeps doing that forever as long as you want to go. Um, for a BST, which is just a certain kind of tree, the time complexity, oh, login, really good. Not really good, pretty good. But for search, insert, and delete, very basic, um, very consistent. That's really important to have for something that everything builds off of. And then additionally, inserting doesn't really matter. They can be inserted in any order. You'll see this later on, but yeah, it's basic overview of trees.
Yeah. So, just like last time, we're going to have a node, right? And all that this tree is just a collection of nodes that are all pointing to each other, right? So, just like with a linked list, each node is going to have an element. This can be an int. This can be a struct. It can be whatever the hell you want it. Okay. Next up, we have two pointers. Right now, remember what a pointer is. A pointer is simply a very special data type that points to the memory address of something else, right? Now, what do these pointers point to? They point to other nodes, right? And these nodes are going to point to other nodes and so forth. It's going to end up looking something like this, right? Now, real quick, let's do a tree implementation in C++ to really get into how it works. So I'm going to include IOStream. I'm going to use namespace standard, just clear up syntax. I'm going to create main. Right now, the easiest way to create a node is to actually just use a struct. So I'm going to do struct, not nide, node. Now, what is going to be inside this struct? Three things. First, you're going to have int data, and then you're going to have node star left and node star right. All that left and right is just like in this, it's the left and right pointer to the next nodes, right? So let's just make a bunch of nodes and create a tree out of them, right? And just do it ourselves. We have node A, node B, node C, node D, node E, node F, node G. And let's just do up to G. Now, we want A, we just created all these nodes, right? And we want A to point to B and C. So we have A dot left is equal to the ampersand B. All of this ampersand is it just says that it's a memory address, right? So we're not actually pointing to all the data that's in B, only the memory address that represents B, right? A dot right is equal to ampersand C. And before we move on, let's just give all of these give all this data. So what I'm gonna do is I'm gonna create what's called a constructor, right? All that a constructor does is it says when I create this data type, I'm gonna fill it with this stuff, right? So we're gonna do node int data, and we're gonna do data is equal to data left is equal to right is equal to null pointer. Now, what the heck does this mean? Okay. When I'm inputting data here, that's basically just stuff that I'm gonna give you a long story short. This, let's see, one, two, and I'm basically going to be filling all of these with just these data values to make it easy for us, right? So basically, when I'm using this node, let's actually just rename this from data to something else, value, so I can explain it, right? Basically, what's saying is this data is just this, and we're going to be filling it up with value, right? And we're gonna make left and right null pointer, right? Now, let's say that I wanted to connect all of these, right? We're gonna be doing something a little different. Like I said, here we got a dot left is equal to b, a dot right is equal to c. We got b dot left is equal to ampersand d, b dot right is equal to ampersand E, right? So basically what I have so far is I have A pointing to B and C, B pointing to D and E, and then I have C is pointing to F and G, right? Now, how am I going to print all these out, right? Because I can't just do a for loop like we were doing last time because they're not all just in order, right? So we're going to do something called in order search. So I'm going to create, it's called a recursive function, and we don't have time to get into recursion right now, but basically it's just a function that calls itself. And what this is going to do is it's going to go through the entire tree like this, right? First, we have A. I want you to imagine that this circle right here is A. And then we're going to look to the left and we're going to find, oh, there's a B. And we're going to look to the left there and find, oh, look, there's something else there. And we're going to look to the right because there's nothing else on the left. And then we're going to go up again, but there's nothing on the left or the right. So we're going to go up. And then we're going to go to the right again. And basically, we're just going to be searching through the entire tree and printing out all of the values, right? So I'm going to create a function called in order node star base. And then what we're going to do is if base is equal to null pointer return. Outside of that, what we're going to be doing is see out base data. So basically what we're doing here is we're saying this is our base case. Basically, if we're not at a node anymore, we're just going to return, we're going to be done. But otherwise, what we're going to do is we're going to see out the data that we're currently sitting on, right? And then we're going to call this again. So we're do in order. I always spell this wrong. Base left in order base right. Okay, so now what we're going to be doing is I'm going to call an order on this tree. Now, the head branch of all this is A. So I'm going to call in order on, I'm going to call in order on A. Now let's run this and see if this works. And what we see here is that we're actually doing an in order search on this entire tree. Now you'll notice that this doesn't print out 1, 2, 3, 4, 5, 6, 7, right? And the reason is you'll see that this right here is 1. Let's do this real quick. This right here is 1, right? It's actually not going to go well. This right here is 2, but this is 4, right? Because this node right here is 3. So we're basically just going in the in order search direction. It's basically going to be a depth first search instead of a breadth first search. I'm sure you don't know what that is, but yeah. Mac, you got anything else for us?
Mm-mm. I feel like you just need to know a lot of this, like the in order search, that's probably going to be an assignment for you in itself. And so you really just need to know like the basic of like how trees are set up. And then I feel like the best way to really learn is to follow along with this and do it on your own. And then it'll quickly make sense.
All right, y'all. You have a wonderful day, and I hope that this was very informative for y'all.